All right, so we're going over 11.1.2, multiplying and dividing rationals. Okay, so part two of the kind of rational expressions. So with these, you're still going to be trying to cancel out like factors. Okay, the only thing's different now is that we're going to multiply expressions or divide expressions before we do that. Now, just remember that you almost treat rationals just like you would a fraction, right? So fractions are treated the same way. So if I'm looking at this first problem, let me give me an example. If I had, let's just say, 1/2 times 1/2. Okay, to multiply a fraction, remember that we multiply the numerator, multiply the denominator, and in this case I would have 1 times 1 is 1, 2 times 2 is 4, right? Okay, if I was to divide these two, okay, before I do this, I flip the second fraction, I take the reciprocal of it, so it becomes 2/1, and then instead of division, now it's multiplication. Now I do the same thing, multiply across, 1 times 2, 2, 2 times 2, 1, 2. All right, so when we're dealing with the rationals, it's the same thing. We're still going to be multiplying across, or if it's division, flip the second fraction and then multiply. So we're going to apply that kind of to this idea of the rational expressions. Okay, so like the first problem, I'm going to have some kind of expression on the top, another one on the bottom, okay, another one on the top over here, and another one on the bottom here. Okay, so if I'm multiplying those together, that means that the 2x plus 1 and the x minus 1 are in the numerator. They're in the same numerator. They're just on separate fractions or rationals. And then the x minus 1 and the 3x plus 1 are also both in the denominator. So what I can do here is if x minus 1 is here in the numerator and here in the denominator, I can cancel those out. Those become 1. Now, you might think, okay, 2x plus 1 over 3x plus 1 is very similar, but it's not the same. So now I have 2x plus 1 over 3x plus 1. And there's nothing I can do with that. I know that you might see an x over an x or a plus 1 over plus 1. Those don't cancel because they're separated by plus. If they were separated by, let's say, 2x times 1 and 3x times 1, I could cancel all of this, and I'd have 2 over 3. But because they're separated by addition, you cannot cancel those. Okay, that just doesn't work. Okay, so this is pretty much what you end up with. Okay, the other thing is that in this section, it starts asking about excluded values. Excluded values are numbers that if I plug them into the denominator, it would make it equal 0. Because remember that, think back, if I had a number and I divide it by 0, that makes no sense. It's undefined. Okay, or we just write out undefined, right? So with this problem, I want to think, what would I plug into the denominator to make it equal 0? And to look for that, I go back to the original problem when it's factored. I don't go back to my simplified expression at the end. I need to look at when it was factored first. And here, think about, what would you plug into x minus 1 to make that 0? Well, 1, because 1 minus 1. So think opposite, right? So my first excluded value is that x cannot, that's what the line cross through means, cannot equal 1. The next excluded value is going to come from 3x plus 1. Now, that might not be as obvious because of that 3 in the front, so what I can do is set that equal to 0 if you have a number in front of the x, and then solve for x. So minus 1, divide by 3, and then right there's the excluded value, negative 1 over 3. Okay, so those are your excluded values, those two there. And then that's your simplified expression. So if it asks for an excluded value like it does in the first section that I'm showing you, then you're going to want to put that there. Okay? All right, so let's look at the next problem. Okay, so now we've got division. All right, so now I've got, let's say, this is a lot like part B, x plus 2 over 3x plus 1 divided by 3x plus 1 and x minus 1. Okay, sorry about that. Okay, so now, remember the first thing I do with the division is I gotta flip or take the reciprocal of the second. So this one stays the same. This one flips, so now 3x plus 1 is on the top, and x minus 1 is on the bottom. And I'm going to multiply. Now, before I cancel out the factors, let's do that excluded value first. So from 3x plus 1, well, that's the same thing as over here. So I could, whatever it is, just set it equal to 0. Okay? Obviously, yours is not. It's going to be 2x plus 1, right? So you'll set that equal to 0. But I already did the math for that one, so I already know that's negative 1/3. All right, and then here that would be also 1, just like the last one. Okay, obviously the answers are not, the excluded values are not going to be the exact same numbers every time. It just depends on what numbers you have down there. Now we can cancel out the factors and end up with x plus 2 over x minus 1. Okay, with those excluded values there. Okay? Okay, now we're looking at, let's take a look at this one here. They're trying to trick you on this one. Don't be fooled. All right, so here I've got, let's say, 2x plus 1 over x minus 5. Then over here, I've got 1 plus 2x. Actually, let's change this. Let's make this 5x minus 1. And then over here, we're going to do 5 minus 1x. Okay? So you got to decide, okay, first, what are the common factors? Well, I'm sorry, not common factors. What are the excluded values? Because it's already factored. Here I got to set this equal to 0. Here I want to set this equal to 0. Okay, so I'm going to do over here. So now I got 5x minus 1 equals 0, and 1 plus 2x equals 0 plus 1. So then I've got 1 divided by 5. So my first excluded value is x cannot equal 1 over 5. And then over here at minus 1, divide by 2. So my other excluded value will be negative 1 over 2. And notice how for this one, I didn't look for the excluded value until I did the flip, until it was multiplied, or the two rationals would be multiplied. Whereas here, I did it right away because I have multiplication. So before the excluded value, make sure you flip it first before you look for those excluded values. And also notice that I'm only finding the excluded value from the denominator. Because again, we're looking at what would make the denominator equal to 0, not the numerator. Numerator doesn't matter, okay? So only look at the bottom. Okay, so now I got my excluded values. Now what are common factors? These look the same, but notice it's 5x and 5. That's not a like term. And 1 and 1x, those are not the same, so those don't cancel. Here I have 2x, and even though there's a 1 there, look, I have 2x there. Here I have 1 there. So those are actually like terms, or like factors. They're just written a little different, or written in a different order. So now I have 5x, or sorry, not 5x, but 5 minus 1x over 5x minus 1. And again, this 5 doesn't have an x, and this 1 doesn't have an x, and that's why they're not like factors. Okay? Okay, this next one right here, part D, notice it has a 3. So when you would do this, expand that out. Expand that out. You're going to have 3 minus y minus 2. So you're going to have y minus 2 times y minus 2 times y minus 2. And you can only cancel 1 y minus 2 for every y minus 2 on the bottom. Okay, so I'll do a quick example like that one. Okay, so if I've got x minus 3 squared over x plus 1 times x plus 3 and x minus 3 here, and over here I got 5x minus plus 1. Okay, I've got two of these, right? So that means I've got x minus 3 and x minus 3 again. And I have an x minus 3 over here, so one of those, only one will cancel, and I still have one left. Okay, and then nothing else is a like factor, so I'm going to have x minus 3 in the top and 5x plus 1. And then on the bottom, I'm going to have x plus 1 and x plus 3. Excluded values in this case, x cannot equal -1 and x cannot equal -3. Okay? And again, you only got to do that if it asks you. Not every problem does. So make sure you're paying attention to the instructions. Okay, going down here, same idea, except now we've got some factoring and we got to do first before we start canceling everything out. And notice that this one says state any values of the variables that need to be excluded. So that's asking for excluded value. This second one does not ask you to do that. So we do not need to write those excluded values in this one. Okay. And actually the rest of these homework, this assignment, you don't need to. All right. So let's look at a problem like this one. Okay. All right, so for this next one, 11-17, I'm going to be focusing in on that problem there. Zoom in a little bit for you guys. A little bit clearer to see. That last problem, again, was 11-16. It's like I wrote that on the board, 11-16. This is 11-17. So this is what this is similar to. All right, so first, division, right? So that means I'm going to have to flip. First one stays the same. This becomes multiplication. Now the 2x squared minus 4x minus 5 is on the numerator, and then the x squared plus 3x minus 10 is in the denominator. Okay, so now what we got to do is we want to be able to cancel out factors like we did in the last one, so we've got to do some factoring. So here on that one, I'm going to want to do the GCF factoring. Okay, here is going to be x and box, because I got a leading coefficient bigger than 1. Here I'll also have to do x box. Okay, this one I can do just the x because that leading coefficient is just 1. All right, so let's get busy. All right, so first one, let's start with the GCF. What's the common factor here? Well, it's a 4. I can divide a 4 into both of those, so I divide out 4. And then the new factor I have is x plus 2, because 4 times x is 4x. 4 times 2 is 8. Okay, now I'm going to use the x in the box to factor out here, and diamond here, and then x box here. Okay, so let's start with that one. All right, let's do the x box there. So, and by the way, when you guys work on these problems, if you run out of room, you can always just do it like on a separate piece of paper, and then take a picture of it and add it with your Schoology assignment. Okay. All right, so first, remember when you do the x box, first term times the last, so 2x squared times -3. Then -5x on the bottom. Two numbers that multiply to -6 add up to -5. Okay, you might think, okay, 3 and 2. Okay, well, if I do -3x times 2x, that gives me -5. I'm sorry, -6 when I multiply it. When I add those two, it's only -1, not -5. Okay, if I make them, let's say, both negative, they'll add up to -5, but they won't multiply and give me -6. It'll be +6. And if I make the 2 negative, same problem. It's 1x when I add it, but it works for the multiplication, but not the addition. So 3 and 2 doesn't work. So you got to be careful with like 6 and 5 and some other numbers. That might not be the combination you need. So let's try 6 and 1, because 6 times 1 gives me 6. And I can subtract 6 minus 1 to get 5. But in order for this to be -5, 6 has to be negative. So that works. -6 times 1 is -6, and -6 plus 1 gives me -5. So now we can set up our box. Now remember with the box, the first term in the expression, 2x squared, goes in the first box. The last term goes in the last box. And then the two terms you found right there go in the other corners. Okay, now I just got to figure out that first term up here where that 2x goes. Okay, well, I know that these two have a common factor of 2x, so the 2x goes there. So 2x times x gives me that term. X times 1 there. 2x times -3 there. So there's my factors for that first one. 2x plus 1 and x minus 3. Okay, now we're going to work on that one with the x box, so I'll do that over here. Same steps. I got negative 10x squared, negative 4x. What two numbers multiply to give me that number? It would be all right. Some of you might have caught that there's no number that works. So I mistakenly, when I set this problem up, I forgot this is supposed to be a 9. All right, so that means 9 goes down here. All right, so now again, two numbers that multiply to 10, negative 10, but then add up to negative 9. Well, 10 minus 1 will give me 9. So that means that negative 10, or the 10 has to be negative -9 when I add it. Okay, so set up the box now. First term, 2x squared. Last term, -5. Two terms you found right there. Okay, 2x squared and negative 10x have a common term of, or factor of 2x. So x there, x times 1. Oh, look, there's the same factor like over there. 2x times -5. Okay, so there's my factors, 2x plus 1. You can see we got some like factors now. Okay, one more. Now we just got to do the x with this last one. I'll do it right here. So I got a little bit of room. Okay, so I got negative 10x squared. I got 3x there. See it right away, it's 5 and 2x, and that's a positive 3, so that means this has to be -2. The smaller number has to be negative. And remember with these ones, because it doesn't have a number in the number bigger than 1 in the front, I can take those numbers and go straight to the factors. So now x plus 5, x minus 2, and now let's start looking for those like factors, okay? All right, so now let's see. We have x plus 2. Oh, there's no x plus 2. I got 2x plus 1. There's a like factor. Okay, anything else? I think I actually had wanted more of them to cancel out, but I kind of made a mistake. Let's change some things up. I'm going to make this a negative. Sorry if I'm messing with you if you're taking notes. Just make that negative, which then changes this over here, which now this will be, oh yeah, so over here this will be negative, which just means we switch the signs here. Okay, so that'd be -5 instead of +5, so that's negative, that's positive. I think that's what I wanted before. All right, so basically I just changed up the sign so I could get a +2 here. And now those two cancel. Look, I've got -5 and -5. Those two cancel. So now all I have left on the top is a 4, which by the way, if that 4 were to cancel out, and you have nothing in the top, remember like yesterday's lesson, you have a 1. So you have a 1 there. Okay, so basically I end up with 4 over x minus 3. Now, if it does ask you for the excluded value, that would happen in this step right here. You would have 1, 2, 3, 4 different excluded values if you were to, if you were asked about that. So it'd be 3, 5, -2, and then you'd have to solve for, or set that equal to 0, and you get -1 over 2. Okay. Okay, as you guys work through part D, same thing, guys. It's just multiplication. You don't have to do that step where you flip the second one. Okay, in the next page here, same thing here. We're going to flip that second one and then cancel out the like factors. Notice that we're going to have a 6. Once I flip this up here, I'm going to have 6 over 9. So I'll give you an example of what to do there in that step. So let's just say that you're working through this. And, I'm at this point, I've done some factoring. Now I'm going to cancel out some factors, x plus 1, let's see, x minus 5. Okay, that's all I can cancel out for like factors. So now I have 8 times x plus 3 in the numerator, and then just 6 in the denominator. Okay, and you may have another factor down here, you may not. But now just remember that 8 and 6, I can also reduce that or divide those out and simplify them. So now think, if I had 8 over 6, like a fraction, I'd reduce it by dividing both of them by 2. So I can divide that by 2, I get 4. And then I still have x plus 3. And divide that by 2, and I have 3. Okay? So if you have like single numbers or monomials on the outside by themselves, you can reduce or divide those. Okay? Or maybe it'll be a number that evenly divides into that one. Okay? let's say that you've got 4 and then x minus 1 over 2 x plus 2. Well, 4 divided by 2 is 2, and that remains in the numerator. Or it's almost like I divided both of them by 2, and that's a 1, so I don't need to write the 1 on the bottom. Okay? Okay, in this next section, 11-20, you basically, first, it's asking you to find those excluded values. At this point, it's just reminding you that, if it's raised to the second power, that you have to expand it first. But first, look for those excluded values and then simplify. Here, you're going to go ahead and use that same idea of expanding them. But also, again, it's asking you to look for those excluded values, expand them, cancel out what you can cancel. But look, you got a number 8 over 4 in front. So just like I showed you a second ago, try to simplify that. Here in the 11-24, use synthetic division, set that up. Notice that, let me write this one up on the board. So when you're working this one out, you know that, remember, first you got to do the opposite, right? So -2, and then you got to write the coefficients of each of the numbers in the part that you're dividing by or dividing into. So that's a 1. Then notice it goes from 4 to 2 in the powers of the exponents, right? So that means you have a missing term. So don't forget to write then that missing term and put a 0. Then I got -7. Then I have 3, and then 18. Okay. So bring the first one down. Remember, multiply. What you multiply goes here, and then you add, and you multiply again until you get down here. Remember, that last number is going to be a remainder. If you do have a remainder, whatever that number is, make sure that number goes over your divisor at the end. Okay, if it's a negative or a positive, make sure you put a sign in front of it. And then for the answer here, that first term, okay, which you notice is a 1, if that's to the 4th, this will be to the 3rd, and then you write out the rest of the coefficients, okay? Okay, on that last question, you're just graphing out 2 times the sine of x and y equals cosine of x on these axes. So go back and look at your previous assignments in chapter 9, like we did last week when we were graphing these, and check those out. All right, and that's it.